I am Dr. Atma Selvi, Assistant Professor in the Department of Food Process Engineering at SRM University, Chennai. Dear students, in this module, you will learn the process of making various concentrated food products. Examples of concentrated food products are condensed milk, condensed fruit puree, corn syrup. These concentrated products can be used instantly during preparation of various food products. As we all know, concentration of liquid food is a process of removal of water, and this process is done to reduce the weight and volume of the liquid food products. So the main purpose of concentration is to reduce packaging, transportation and storage cost, and also to improve the stability and handling of the product. The objective of this model is to study about the methods of making various concentrated liquid food products. As we have now learned what is concentration and why concentration is performed, we will move on to learn the process of making various concentrated dairy products. Fluid milk contains approximately 88% of water. Concentrated milk products are obtained by the partial removal of water. Dried dairy products are produced by the greater removal of water. These dry products contain around 4% moisture content, and because of low moisture content, these can be preserved for longer time. As I already told you, the benefits of concentration includes increase in shelf life of the product, convenience in usage, product flexibility, and decreased transportation and storage cost. The various concentrated dairy products are evaporated skim milk or whole milk, sweetened condensed milk, condensed buttermilk, and condensed whey. First, let us see the procedure involved in making evaporated milk. Evaporated milk can be produced from either whole milk or skim milk. Evaporated milk is a milk product which is produced by the removal of 60% of water from the ordinary milk and is usually sold in cans. Production process of evaporated milk. Initially, the raw milk is transported in refrigerated tank trucks from the dairy farm to the plant. Milk is tested in the plant for odor, taste, bacterial count, and sediment. The composition of milk protein and milk fat are measured by passing the milk under highly sensitive infrared lights. Then the milk is pumped through filters and transferred into the pasteurizer. Pasteurization of milk is done in two ways. The first method is high temperature short time method, which is abbreviated as HTST. In this process, milk is heated at a temperature of 72 degrees centigrade for 15 seconds. And the next method is ultra high temperature or UHT. In this method, milk is heated at the temperature of 138 degrees centigrade for 2 seconds. The pasteurized milk is transferred into an evaporator. The boiling of milk is continued in vacuum chamber. Boiling point of the milk is lowered to 40 to 45 degrees centigrade when the milk is evaporated in vacuum evaporator. Advantage of vacuum evaporator is the liquid boils at low temperature. Hence, the condensed milk will have less cooked flavor. Evaporation of milk continues until the solid concentration reaches 30 to 40%. The evaporated milk is then homogenized by forcing it under high pressure through minute holes. Homogenization process helps in breaking the flat globules into tiny uniform size particles, resulting in the enhancement of color and stability of the milk. Then to make the evaporated milk creamy and smoothie, pre-measured amount of stabilizing salt like potassium phosphate is added. The evaporated milk is fortified with vitamin D by passing it through series of ultraviolet lights. Finally, the evaporated or condensed milk is piped into pre-sterilized cans which are vacuum sealed. So far we have learned the process of making condensed milk. Now let us learn the process of making sweetened condensed milk. Milk from which water has been removed is called condensed milk. Sweetened condensed milk is the condensed milk to which sugar is added as a preservative. Sweetened condensed milk contains around 8% fat, 45% sugar and 20% solids not fat. Sweetened condensed milk is mainly used in the manufacture of confectionery and chocolates. So, in this process, milk powder and water are filled in a kettle and mixed using dynamic or static mixer. Mixing is important to produce uniform mass. Then the sucrose is added according to the requirement. Then according to the specification, required amount of fat or oil is added into the mix using positive pump. The preheated mass is then filtered and homogenized between 50 to 150 bar prior to final eating. The final eating is done using direct or indirect eating system at a temperature of 80 to 105 degree centigrade. The sweetened condensed milk is fed to the 3-stage flash cooling system in which sudden pressure drop in the product occurs and thus the content is cooled down. Fine crystals are obtained by adding the seeding lactose between the second and third stage. The product is extracted using a positive displacement pump and transferred to the lactose crystallization tank for further crystallization. After the lactose crystallization, you will get sweetened condensed milk. Let us learn the process of making condensed buttermilk. Buttermilk is a byproduct of the butter industry. Buttermilk can be evaporated as such to obtain condensed buttermilk, and condensed buttermilk needs to be stored at low temperature. Or buttermilk can be added with skim milk and dried to produce skim milk powder, and this blended product may undergo oxidation process readily due to the existence of higher fat content. Next, the process of making condensed whey. Superior quality of whey is formed in the process of cheese making. Cheese whey is evaporated as such to produce condensed whey. Whey consists of fat, lactose, beta lactoglobulin, alpha lactalbumin and water. The fat is usually removed by centrifugation and churned to get whey cream. And whey cream is used in ice cream. Whey can also be converted into whey powder by evaporation. So far, we have learned the process of making various milk-based concentrated products like condensed milk, sweetened condensed milk, condensed buttermilk and condensed whey. Now, let us learn the process of making fruit-based concentrated products. First, let us see how to make puree concentrate. Fruit is first heated to make it soft. It is then mashed and sieved to remove skin and seed. The pulp is then filtered many times to obtain specific smoothness. The solution is then depectinized and once again filtered and evaporated under vacuum to obtain particular Brix level. Concentrated fruit puree will have Brix of 2 to 7 times of the original Brix value. Fruit purees usually retain the majority of the fruit's acid, sugar and color content. Let us learn the process of making fruit powder. Fruit powder is usually prepared using spray dryer. Maltodextrin or other wall material are added to the fruit concentrate while spray drying. Wall material is generally used to protect the nutritive value and the flavor of the fruit spray dried. Fruit concentrate are atomized into the spray dryer by passing through nozzle using high pressure pump. The final product will be in the form of powder. Next, we will discuss about the process of making corn syrup. Corn syrup is the food syrup which is made using corn or maize starch. It contains varying amount of maltose and higher oligosaccharides. Corn syrup is used in the food product to enhance the flavor, increase the volume, softening of texture, and for prevention of crystallization of sugar molecules. High fructose corn syrup is the product produced from corn syrup by converting large proportion of glucose into fructose using the enzyme D-xylose isomerase. Now let's learn the process in detail. Historically, corn syrup was produced by adding dilute hydrochloric acid to cornstarch and the mixture is heated under pressure. Currently, corn syrup is produced by multiple step bioprocess. The variety of corn which is used as a primary source of corn syrup is yellow dent corn. Other ingredients used in the preparation of corn syrup are sulfur dioxide, hydrochloric acid, water and various enzymes. Corn syrup is produced in the plant known as wet corn mill. Dried and shelled corn kernels are transferred into the mill with help of truck or rail cars. In the mill, corn is unloaded into storage pit where weighing and sampling is done. From the storage pit, kernels are passed over the set of vibrating screens or perforated metal grates with the help of conveyors. In this step, the impurities associated with corn kernels are removed. Lighter impurities are removed by controlled air blast. The electromagnets are used to capture or remove any nails, screws or bits of metal. After cleaning, the corn kernels are placed in a series of large stainless steel tank called as steep tank. Warm water containing small amount of sulfur dioxide is made to circulate through the steep tank. The sulfur dioxide react with the water to form weak sulfurous acid solution. Softening of kernel continues for about 20 to 40 hours. This facilitates easy separation of starch from the corn. The germ consists of oil is removed from the softened corn kernel in the grinding mill. The mill consists of two discs. One is stationary and the other rotating. The clearance between the disc is adjusted to tear the kernel apart without crushing or damaging germ layer. The resulting pulp is transferred to a series of cyclone separators called as germ separators or hydroclones. The germ with lesser density than other parts of corn kernels are separated out of the pulp by centrifugal force. The germ which are separated are passed through series of screens and washed several times to remove remaining starch. The clean germ undergo heating and pressed to extract corn oil, which is further processed into food products and soap stock. The residual materials obtained from germ separator or slurry containing starch, protein and fiber. This slurry is made to pass through set of mills to remove or tear the starch from fiber. The fiber is moved by passing it through series of screens and the fiber is then dried. These dried fibers are used as animal feed. As the fiber is removed, the slurry will now have starch and protein in it. The slurry is then passed through set of centrifugal separator which rotates at higher speed. The starch has higher specific gravity or density than the protein and hence the heavier starch will be separated from lighter protein using centrifugal force. The separated protein is called as gluten, which is dried and used. The starch thus obtained is diluted with water before washing and filtered nearly 8 to 14 times to remove the remaining protein molecules. After filtration, starch is rediluted with water and passed through second set of centrifugal separators. The starch obtained from these separators is more than 99.5% pure. A part of this cornstarch is dried and packed, which is used in food products, building materials, or to manufacture various chemicals. The remaining starch is converted into corn sweeteners such as corn syrup. So far, we have learned the process of separation of cornstarch from corn. Now, let us see how to convert the remaining cornstarch to corn syrup. Conversion of cornstarch into corn syrup. Cornstarch is converted into corn syrup by acid hydrolysis process. In this process, the cornstarch is mixed with a weak hydrochloric acid solution and subjected to heating under pressure. This corn syrup is filtered or subjected to clarification process to remove undesirable flavor or color. It is further refined and evaporated to reduce the amount of water and to make it concentrated. Now let us see the production process of high fructose corn syrup. In some applications such as soft drinks, a sweeter taste is desired. The sweetness of corn syrup is enhanced by the process of enzyme conversion. In this process, the dextrose sugar present in the corn syrup is converted into fructose in the presence of enzyme under the controlled condition of temperature, pressure and acidity. The powdered high fructose corn syrup is produced by the evaporation of water from syrup followed by the encapsulation of the powdered grains to prevent the reabsorption of moisture. Pure fructose crystals are obtained by the further processing. Now, let us learn the process of making concentrated egg product. The concentrated egg product or the processed form of egg meant for commercial or home use. Anti-caking agents like sucrose, glucose, free corn syrup or sodium silicoaluminate are sometimes added to the concentrated egg products to bring about free-flowing products. Whipping additives such as sodium lauryl sulfate may be added to the egg white. During the process of making concentrated egg products, eggs are exposed to high temperature. Carbohydrate is generally added to enhance the resistance of egg to the heat damage and also to improve the stability and flow characteristic of the egg product. The different concentrated and dried egg product available in the market are whole egg or yolk solids, dried eggs or scrambled egg mix, concentrated egg white, free flowing whole egg or yolk solids, stabilized or glucose free whole egg or yolk solids, blend of whole egg and or yolk solid with carbohydrates. These concentrated egg product must be stored in cool and dry place. Now let us learn the process of making concentrated egg white. First, the egg yolk or albumin is separated. They are then churned, filtered using ultrafiltration. The filtered mass is then pasteurized and evaporated to the required concentration. As egg tends to coagulate, few additives are added to prevent the egg from coagulation. Egg white is subjected to pressure when it is made to pass through the narrow gap between the membranes during ultrafiltration. This exerts a shear force on egg white which may cause damage to its functional properties. In addition to this, the heat applied on egg white during pasteurization also have negative impact on its functional properties. Chemical additives added to the concentrated egg white to restore its functional properties. Let us learn the process of making dried free-flowing white eggs. Egg is first churned, filtered and pasteurized. The pasteurized whole egg is sprayed with 2% silicoaluminate which is added as anti-caking agent. This dried egg powder can be used in all recipes such as cakes, cookies, etc., which require liquid whole egg as major ingredient. Next is concentrated omega-3 fatty acid. Omega-3 fatty acid is the polyunsaturated fatty acid which contains double bond at the third carbon atom from the methyl end of the carbon chain. There are 3 omega-3 fatty acids which play major role in human physiology. They are linolenic acid, eicosapentaenoic acid and docosahexaenoic acid. These fatty acids are considered as essential fatty acids because human body cannot synthesize them. These must be consumed as a part of normal diet. The major source of these omega-3 fatty acids is fish and fish oil. These essential fatty acids can also be derived from plant source such as flaxseed oil, but these must undergo metabolization in the body to produce EPA and DHA. Let us learn the process of producing omega-3 fatty acid using urea adduction. Urea adduction is the simplest and efficient technique for concentration of omega-3 fatty acid. The complex formed between urea and straight chain saturated fatty acid can be efficiently separated. Free fatty acids are mixed with an ethanolic solution of urea for complex formation. Urea molecules form solid phase complexes with saturated and monounsaturated fatty acids and crystallize out on cooling and may be removed by filtration. Omega-3 fatty acid can also be concentrated using liquid chromatography, supercritical fluid extraction and distillation process. Now let us see the process of making omega-3 fatty acid using fractional distillation. As we all know, different fatty acids have different melting point. This process utilizes the difference in melting point of different fatty acid for concentration. The melting point of fatty acid depends on their degree of unsaturation. As the temperature of the mixture of saturated and unsaturated fatty acid decreases, the saturated liquid phase becomes enriched with unsaturated fatty acid. By this way, we can separate the unsaturated fatty acids from saturated fatty acids. Let me summarize this lecture. We have discussed about various dairy products like evaporated skim or whole milk, sweetened condensed milk, condensed buttermilk, condensed whey. Evaporated milk can be produced from either whole milk or skim milk. Pasteurization of milk is done by high temperature short time method or ultra high temperature method. Pasteurized milk is evaporated in vacuum evaporator. Sweetened condensed milk is a condensed milk to which sugar is added as a preservative. Buttermilk or whey is evaporated to produce buttermilk powder or whey powder. Fruit juice can be evaporated to produce fruit powder. High fructose corn syrup is the product produced from corn syrup by converting large proportion of glucose into fructose using the enzyme D-xylose isomerase. Urea adduction is the simplest and efficient technique for concentration of omega-3 fatty acid.